Hello everyone, welcome to the lecture. So in this lecture, we will solve your activity question 7.1. Okay, so let us start with the fourth question. So this is the question. This is a function fx equals to x minus 1 by x square minus 5x plus 6. Then the number of point at which the function is not defined. Okay, that means the function will not be defined when this term, that means x square minus 5x plus 6, will be equals to 0, right? So clearly we can see that from here we will find the root of this equation will be 2 and 3, right? That means at 2.2 and 3 the function will not be defined. Okay, so the answer is 2. Okay. Okay, this is the next question. Which of the following are collection of set? Collection of rational numbers. So this is a okay. So let us first recall what is the definition of set. Set is a well-defined collection of objects, right? Okay, this is a well-defined collection of objects. Okay, so the collection of rational number is a well-defined collection. Okay, so collection of rich people in India. This is not a set, right? Because rich people in India, this collection is not well defined because people can be rich in according to me, but they cannot be rich according to you. Okay, so it basically varies person to person. So which particular thing which varies person to person or things to things, so this is not a well defined collection. Okay, so collection of rich people is not well defined. Okay, because if someone says me to give a collection of well defined people, maybe I will give a list of people which may be not same as your list of people. Okay, so this is not a well defined collection. Okay, so this is not a set. Okay, collection of movies directed by Rituparno Ghosh. This is a well-defined collection, right? So everyone will be, everyone according to everyone, this set will be same. The movies directed by Rituparno Ghosh. Similarly, collection of novel written by George Orwell is also a set. Okay, collection of good actors and actresses in India. It is again not a set, right? Because actor can be good from my point of view, but they cannot be good from your point of view. So it is again varying from the point of view. Okay, so this is not a set, is not a well defined collection of good badminton players in India. This is again not a well defined collection. Okay. Okay, so these are the correct answer 1, 3, and 4. Let's move to the next question. This is the next question. We have the given graph. Now we have to conclude. So consider the following statement in the interval minus infinity to 2. That means in this interval, the function is increasing. So in this interval, function is like that, right? Which is clearly decreasing function. Hence, this is incorrect, but this is okay. Sorry, this is in the interval minus 2 to 2, minus 2 to 2. So we can say that minus 2 to 0, the function is increasing, but 0 to 2 is decreasing, right? So this is neither increasing nor decreasing in the interval minus 2 to 2. Okay, so this is again another incorrect answer. Okay, in the interval minus 2 to 0, the function is increasing. So in the interval minus 2 to 0, that means in this interval, that means this portion is clearly increasing, right? So this is the correct answer. In the interval 0 to 2, the function is decreasing. 0 to 2, that means this portion of the function, this is clearly decreasing, right? This is also correct. In the interval 0 to infinity, the function is increasing. So 0 to infinity means in this portion. So we can see again the function is decreasing in the interval 0 to 2 and it's increasing after 2. Okay, that means it is neither increasing nor decreasing in the interval 0 to infinity. So this option is incorrect. In the interval 2 to 3, the function is increasing. Okay, so in the interval 2 to 3, the function is like that, which is clearly increasing, right? So this is a correct answer. Okay. Okay, let's move to the question 10. First option is fx equals to mx plus c is one function from R to R where m is an arbitrary. Okay, so clearly this is a line, something like that. Okay, so it will obviously pass the horizontal line test, right? So this is a one function. So this is correct. Okay, fx equals to x squared plus bx plus c is an onto function from R to R where b and c are arbitrary real number. This is incorrect, right? So a parabola is something like that. Okay, so it will it will be something like that in the upward direction because the coefficient of x square is 1. Okay, so obviously it will have some minimum point, right? It will have some minima. So after that minima, I mean the number less than the minima will be will have no pre-image. Okay, so clearly this is not a onto function. This is incorrect. Okay, so clearly you can see that 1 by e power x means e power minus x. So when x will be tending to minus infinity, e power minus x will be tending to infinity. Right? So this is a unbounded function. This is correct answer. Okay. So the function gx equals to 1 by 1 plus e power x gives a bijection function. Okay. So we can take one function g1 equals to e power x and g2 equals to 1 by 1 plus x. So we can clearly notice that g of x will be basically the composition function g2 comma g2 compose g1 of x, right? So this is the composition function. Now individually these two functions are 1 right? And composition function of 1 function is again 1. So it will imply that g is 1. Okay, and also we can see that if we take any number from the interval any y belongs to 0 1, so there will be a x such that 1 by 1 plus e power x equals to y. Okay, so you can verify it. So you can find the value of x from here. So this will be 1 plus e power x will be equals to 1 over y. So e power x will be 1 over y minus 1. So x will be log 1 minus y by y. That means log 1 minus y minus log y, right? Now y belongs to 0 comma 1 open interval, hence clearly these two terms are defined, hence we can define x, right? Hence for any y belongs to this interval we can find the x such that the image of x under the mapping is equals to the point y. That means for any point y we have a pre-image. So this imply that g is onto. Okay. Hence bijection. Okay, so clearly this is a correct statement. Okay, so number of correct statement is basically then 3. Okay, this is the last question of 7.1. So we have a function f equals to x plus 1 over x. Which of the following is correct? So we have to find whether the function is injective or not. Okay, so clearly if we take anything like a and 1 over a where a is not equals to 0, then the functional value of a will be always equals to the functional value of 1 over a, right? And for this type of point only we will get the functional value as same. Okay, now what if we just extract this type of one of these points? Okay, so that means suppose if we take natural number, so we cannot take then 2 and 1 over 2, right? So when the domain is natural number, the function will be injective. But when the domain is r minus 0, the function will not be injective. Okay. So this is not injective when the domain is r minus 0, but this is injective when the domain is natural number. Okay. So for rational number also, the rational number contains these 2 points. So this is not true for rational numbers, but this is again true for integer functions. Okay. So in the integer function, this type of point will not be in the domain. So in the domain of integer function minus 0, the function will be injective. Okay. If f is surjective function in the domain of n and codomain of um, f is q. Okay, so codomain is, if the domain is n, then the codomain is q. This is clear, right? So is it surjective? Is it really surjective? So if we have any point in the codomain, okay, let y equals to 1 plus 1 by 2. Okay, so yeah, so this is belongs to q, right? But can we find any point in the set of natural number or in the set of integers such that the functional value of the point will be equals to y? Okay, so clearly this is not possible, right? Hence both the options are incorrect. Okay, hence they are not surjective because there are some point in q for which there doesn't exist any pre-image. Okay, hence these two options are incorrect. Thank you.